All right, 7/8, we're looking at this article from the Washington Post, and I really liked the simulators it has on it for explaining why we are in the state we are in right now with coronavirus and why it is essential that we flatten the curve. I'm sure if you've watched the news, you've heard quite a bit about that. Right now, if you look at this image right here, you can obviously see this is a little bit old because it's March 13th and we're past this now. But the number of cases is going up what they call exponentially. It's got an exponential curve. It's going up super fast. And that means that it starts doubling day by day. Something that we definitely want to avoid. This very simple infographic here shows that when a healthy person, which is represented by the blue dots, comes into contact with a sick person, that's the disease gets transmitted. Then that person then infects another healthy person and that one. Again, simplified, but it does kind of make sense. And then the purple dots represent the recovered person. So if we replay this one, there's an infected person, it infects someone else, and after they're infected, there's a little period that doesn't show in here, but then they will be recovered. So let's look at this first one. This first one shows if you have an infected person and everybody's allowed to go about their days as usual, and there's no social distancing or anything put in place, it's what we call a free-for-all, very rapidly, absolutely everybody becomes infected. And after a period of time, then there is the recovery. So this one does not show an illness that actually can cause death in the immunosuppressed or the elderly. That's important to note. And when you look up here at the curve of it, this one has a huge curve. It goes right up to the top, meaning that it infects everybody, and then it starts to slow off because people are not being reinfected. Now, the next thing is the quarantine. So this is what they tried to do in parts of China, was actually put this kind of wall up almost and not allow people to get out that were infected. But it's super hard to enforce, and eventually some infected individuals do manage to exit the quarantined area, and pretty soon everybody again is infected. And eventually everyone recovers. So again, got quite the curve there. When we first started hearing about this, we were quick to put in some social distancing. So here we only allowed about 1/4 of the population to be moving. You can see all the other blue dots are stationary. So they're not going to be as easily infected because the population is not moving. And then when we look at our graph up at the top of it, it actually shows a very flattened curve. Not everybody ends up getting infected, and people are recovering well. So we've really minimized that curve up there, which is what they're trying to do. Now they've put into place some extreme measures, which is extreme social distancing. And this simulation shows only 1/8 of the population being allowed to move. So that would be like our healthcare workers and some of the essential services that we need to have out there, whereas all of us are basically in house quarantine, self-isolation, not moving around or interacting with other people very much. And what's really cool to note is look at our graph at the top here. We have completely flattened the curve. And that is basically the goal of what our government and health agencies are trying to enforce right now. So if we all do our part and have extreme social isolation, we can flatten the curve, and we will save a lot of people's health and a lot of deaths as well.